So for this practice problem, we're finding the limit. Let me get my pen here. Finding the limit as x approaches infinity of 1 plus 2 over x to the 8x. And remember that 2 over x is going to go to 0 as x goes to infinity. So this is actually going to be 1 raised to the infinity, which doesn't make any sense. So we need to do some more work here. We want to get this to where we have an indeterminate form, like 0 over 0 or infinity over infinity, so we can use L'Hopital's rule. So remember that any base raised to a power can be rewritten as e ln of a to the b power, and I can drop that power down in front of the natural log. So we're going to use that idea for this one, and we will have the limit as x goes to infinity of e to the 8x ln of 1 plus 2 over x. And since e is a continuous function, we can pass the limit through that function, and we're going to use that notation of the exponent. And we will then have this. Now, if we substitute in, or if we look at this limit as x approaches infinity again, 2 over x is going to go to 0, so I'll have ln of 1, which is 0, and now we have infinity times 0. Again, we want 0 over 0, infinity over infinity. So let's move that 8x to the denominator. And so we're going to have the natural log of 1 plus 2 over x, and then we're going to write this as 1 over 8x. And now, again, 2 over x is going to go to 0, and now 1 over 8x is also going to go to 0. So we'll have ln of 1 over 0, or 0 over 0. And that's what we wanted. So now we can apply L'Hopital's rule. I'm going to rewrite this to make finding the derivatives a little bit easier. So I'm going to rewrite this using negative exponents. So we'll have ln of 1 plus 2x to the negative 1 over 8x to the negative 1. So let's do L'Hopital's rule, and we will have the limit as x goes to infinity. So the derivative of natural log is going to be 1 over the argument, 1 plus 2x to the negative 1. And then we're going to use the chain rule to take the derivative of 1 plus 2x to the negative 1, and we will have negative 2x to the negative 2 power. In the denominator, we're going to use the chain rule again, so we'll have negative 1, 8x to the negative 2 power, but now we need to take the derivative of the inside, and the derivative of 8x is 8. All right, so now that we found the derivative, I want to change this back to using positive exponents and try to clean this up here. So we've got 1 over 1 plus 2 over x, and this is going to be multiplied by negative 2 over x squared. And in the denominator, we have a negative 8 over 8x squared. So we have some definite complex fractions here. This 8x squared, that's 64x. So we can simplify that. And then I want you to see that when we multiply that up, it's going to cancel with the other x squared. So we have 1 over 1 plus 2 over x. I'm not worried about that piece right now. And we have negative 2 over x squared. And then in the denominator, we have negative 8 over 64x squared, if we get rid of those parentheses. Well, we can simplify that. If I divide both of these by 8, All right, we'll have negative 1 over 8x squared. I don't want to rewrite the whole thing just for that fraction. So we'll have the limit as x goes to infinity. I'm going to multiply the top and the bottom by the conjugate, or not the conjugate, the reciprocal of negative 1 over 8x squared. And so I'll have 1 over 1 plus 2 over x times negative 2 over x squared, and then we're going to multiply by 8x squared over negative 1. So now you can see that these x squareds are going to cancel, and the negative 1 is going to cancel with the negative here, and we will have, I'm running out of room here, the limit as x goes to infinity of 1 over 1 plus 2 over x times 16. So I'm going to write that 16 right here. And now, if we evaluate this at infinity, that 2 over x is going to go to 0, and we will have 16 over 1, which means our final answer is e to the 16th power.